another concept, and that concept is to do with numerical data. Remember, in our definition, we talked about the fact that statistics is about handling numerical data. And if we talk about numerical data, what do we mean? So if, for example, we are interested in the average score of students in a class, that means that we have to assign marks to each student and then be able to add those marks up or those scores up and then determine the average. Okay, so that is an issue to do with the typical manipulation of data for us to get a single figure that will represent the rest. So that means that in statistics, the raw material for statistics is actually data. But this data actually comes in different varieties. And if we see figures that have been attributed to particular characteristics, we should know what type of data we are dealing with. So the whole thing is we need to understand, if we say data, what do we actually mean? For example, if we talk about height, what is your height? Okay, we can take measurements and determine your height and say you are 1.6 meters high. So that 1.6 is the data, the data that we are attributing to that characteristic of height. So when we are talking about data, we are talking about figures that have been assigned to particular characteristics. That's understanding is very good for you to understand our later discussions. So attributes that we can measure and assign values to are the ones that we can get figures for and get data sets for and manipulate this data set. Okay, so anything that we can measure or count will fall under quantitative data, or what we can term as numerical data. So if we say define numerical data or define quantitative data, the definitions should actually be the same. Okay, so we assign numbers to the different characteristics that you're looking at, even if it is intelligence, even if it is temperature, even if it is number of cells, we assign these cells numbers. Okay, so we have this numerical data that we are talking about, and it is always this numerical data that we shall be handling in statistics. So this numerical data, which we said can be called quantitative, gives us the amounts or the quantities of the particular characteristic that we are looking for. And usually, because we assign these figures can be ordered or mathematically manipulated. We can basically say that in a class of 4 students, one student is 2 years, another student is 3 years, another student is 5, and the other one is 7. Okay, but we can arrange these numbers in a particular order, and we can also decide to group them. So this is basically what we are saying, that okay, we can have these numbers just written without any particular order, but we can also decide to manipulate these numbers. And for example, we can add them up and divide them up by the number of students, and then we get the average age for these 4 students in a particular class. This is what we are basically talking about here. Okay, so that means that if we have these attributes or these numbers, we can do anything we want, whether it is multiplication, subtraction, or even addition, or even determining the average. So we have 2 types of numerical data, or we can say 2 types of quantitative data. We have what we call categorical data and numerical data. And then under each we have, for categorical data, we have ordinal data and nominal data. And then for numerical data, we have continuous or discrete data. So please, in different resources, if you see something to do with types of data or types of quantitative data, they will usually point out four types. So you can have continuous data standing alone, discrete data standing alone, ordinal data standing alone, nominal data standing alone. If you get something like that, don't get confused. Okay, so let us look at each of these and understand them quite well. And of course, we shall give examples to illustrate this. So when you say discrete, if I ask you how many people visited the shop today, you will tell me 7 people. That is an exact whole number that you have given me. Okay, it can never be 1.5 people visited. No, it is either 2, 3, 5, 10, 100, whatever it is, whole number. That's a discrete number. And then continuous data, any conceivable value. If you tell me 1, I will accept it. If you say 1.5, I will accept it. 1.8, I will accept it. If you tell me 100, I will accept it. Any value that is conceivable, that it and basically that is applicable, that you can basically use and basically understand. And usually we use this for continuous. Later on, you will understand what we term as variables. We use this for continuous variables. What does that mean? Continuous variable, intelligence, height, weight, these are continuous variables. Meaning that you can't say that you cannot have a person who has a height of, let us say, 1.8. There will always be a person who has that height. Another one will say 1 meter, another 2 meters. And these are all understandable values that you can get for height. And the same applies for weight and other things. Okay? So those are the 2 types of numerical data. So just like the name suggests, categorical data, you have groups. So these groups can be ordered groups or can be groups that are not ordered. For example, if we are going to look at people who visited the clinic, we'll say that 2 of them were male and then 4 of them were female. These are categories. This is gender. Okay, and it doesn't matter whether you say if you started with saying that the 6 were female and then the 4 were male. It doesn't matter. You can start with any. So the order does not matter. That is where we talk about nominal. The order does not matter. Just tell us. Okay, so gender is one of those characteristics. Okay, if it is about occupation, 2 of them were engineers, 3 of them were doctors. It doesn't matter whether you say, you get it. And then ordinal, order matters. Just like ordinal, order matters. So if, for example, we say that someone has gotten a 3rd-degree burn, and then we have another person who has got a 1st-degree burn, if you communicate that information, we can be able to understand who is more severe and who is not, who needs more attention and who does not need a lot of attention. So that means order matters. If we say someone has stage 4 cancer, the order matters. Okay? someone has stage 3, stage 2, order matters. So when you are communicating information, it's very important that you know what information are you communicating and whether the order matters or not. And actually, this also influences the tools that you will use to collect this data, the kind of questions that you will ask. And also this is related to the levels of measurements, okay? The levels of measurements that you will have. And in our subsequent discussions, we shall talk about ratio data, for example. When we talk about ratio data, what does it mean? Okay, so issues to do with levels of measurements are also very important. Okay, and you get to understand them better subsequently. So when we talk about statistics, we are dealing with numbers and how do we manipulate these numbers? How do we handle these numbers? We have two main branches of statistics: descriptive statistics and inferential statistics. So when you talk about descriptive statistics, just like the name suggests, we are having large data sets that we cannot always throw out there because it will complicate people and people will not understand. Okay, people will not understand this data. So we need to manipulate this data such that we can get particular figures that we can easily communicate and people will always understand. So we are looking for patterns, we are looking for different ways of summarizing this data such that it makes sense to anyone. Okay, so with descriptive data, we are talking about measures of central tendency and measures of spread or measures of dispersion. And we'll look at them later on. And they are the last ones that we have here on this slide. We have mean, median, and mode. Those are measures of central tendency. And then measures of spread will have range, you have variance, you have standard deviation. So we'll look at all these measures subsequently. But you basically understand that we have large data that if you see this data, it may not make sense to you, but with the descriptive statistics, we can make this data make sense to you. That is descriptive statistics. Okay, so basically, descriptive statistics is about summarizing data sets such that they can make sense to you. So if we, for example, we have a table of 100 students that have scored different marks in a test, and you look at that table, there is a name and then the score, a name and the score, name and score. You will not make conclusions about that. But if, for example, we say that the average score was 60%, it makes more sense. We can say that the highest score was 90, the lowest score was 10. We can make sense out of that. So that is what descriptive statistics is all about. And then inferential statistics. With inferential statistics, we are basically dealing with how you can make conclusions from given data sets. For example, if we have two drugs, and these two drugs are concerned with how to reduce temperature. So we want to understand which drug actually works better. Okay, so you will need to test these two drugs, and see if it is about reducing temperature, which one works better. Okay, so when you have this data, you may not easily know that this drug works better than that unless you run statistical tests. And this statistical test will reveal to you that indeed drug A is better than B. Okay, so for you to be able to make that conclusion, you need to have used statistics. And that is what inferential statistics is all about. When we say inference, we are saying it means a conclusion. Therefore, This is what I'm saying. The inference drawn from this is that it is a conclusion that you are basically making. But of course, again, these conclusions are based on the proper handling of this data, proper data collection, proper techniques, proper statistical tests that should have been used. And of course, we cannot exactly know certain things. We cannot exactly know. Okay, so if you give me a drug and I have fever, and then you think it is that drug that has reduced my fever, yet maybe the fever was actually going to subside, and by the time you gave me, my fever was disappearing. So we are making conclusions that, okay, when we gave him the drug, the fever went down, but already the fever was actually going down. So sometimes we actually don't know. Okay, so we often say statistics is a science of uncertainty. We always don't know. And we will always never know. We will never know. That's the point. So that's why we say inferential statistics are used for estimates, for making estimations, and for detecting whether indeed, if you said the drug reduces fever, indeed was it the drug or it was something else? And can we do some modeling basically? So, okay, actually, if we increase the dose of the drug, the temperature actually decreases more. Then we are able to say, may be right. So that's the whole matter there.